What up, math nerds and math leads? Who's ready on that math grind? I am. Actually, you know what? I'm not ready. You don't have to be ready if you stay ready. And I'm always on that grind, always on that math grind. All right, so today what we're going to do is we're going to take a look at we're just going to review our transformation rules, right? Because once we have the rules, it's easy to go from our pre-image to our image, right? And if we remember our transformations, we have reflections, translations, and rotations. All right, those are all our rigid motion transformations. And then we have dilations, right? Because as we remember, rigid motion transformations preserve the size and the shape. Okay, so they're all congruent figures. Dilations changes size. So the figures, the image and the pre-image, are not congruent, rather similar. So let's go ahead and go over our rules for transformations. All right, so the first one we're going to go over is our reflections, right? And as you remember, a reflection is a flip over a line of reflection, right? So if we are going to reflect it over the x-axis, right, we have our original x and our original y. The reflection happens. Our new x is our original x. Our new y is opposite our original y. If we're reflecting it over the y-axis, we have our original x and y point. The transformation happens, right? Our new x is opposite our original x, and our new y is the same as the original y. If we're reflecting it over y equals x, or a diagonal line that goes to the origin up and to the right, down and to the left, we have our original x, our original y. The transformation occurs. Right? Our new x is our old y, and the new y is our original x. If we have a reflection over y equals negative x, or a diagonal line through the origin going up and to the left, down and to the right, we have our original x, our original y. Transformation occurs. Our new x is opposite our original y, and our new y is opposite our original x. I know, it's so exciting. Please try to contain yourself. Now we have translations. Translations, they are our slides, right? It's like teaching a dance. We have our slides, okay? And our translation rule is, for the translation, we have h and k. We have our original x and y. Translation happens. We have x either plus or minus h. We don't need that little. And then y either plus or minus k, right? Remember, h is the horizontal shift. And up have our horizontal shift, and then k is our vertical shift, right? So for horizontal, if we go right, it's positive, left, negative. Up for vertical is positive, down is negative. Right? Nothing too crazy there. Okay? Then we have our rotation. A rotation is a turn. Okay? So if we're going to rotate 90 degrees, and remember, unless it says so, we always go counterclockwise. Because remember, when we name our quadrants on our coordinate plane, it's 1, 2, 3, 4. They're named counterclockwise. So when we rotate, unless otherwise stated, we always go counterclockwise. So if we rotate 90 degrees, we have our original x and our original y. The rotation happens. Our new x is our old y, but the opposite of it. And our new y is our original x. Okay? If we rotate 180 degrees, we have our original x, our original y. The rotation occurs. Our new x is our opposite our original x, and our new y is opposite our original y. If we rotate 270 degrees, we have our original x, our original y. The rotation happens. Our new x is our original y, and our new y is opposite our original x. So there's your rotations, right? Those are the reflections, translations, and rotations all represent our rigid motion transformations, right? It preserves shape and size. The pre-image and image are congruent figures. Now, the only one we covered is not a rigid motion transformation, are dilations, right? And as you remember, dilations is when the figure gets bigger or smaller, right? So, our rule for that is we have the dilation, right? We then have our scale factor, right? We have our scale factor. So we have x and y, right? The dilation happens, right? And we take, all we're doing is we are taking what our original x was, right? Taking what our original x was. So we have x, and we are multiplying it. We are multiplying it by our scale factor. We take our original y and multiply it by our scale factor, right? So k represents our scale factor, right? And scale factor is represented by image over pre-image. It's a ratio. Okay? If k is greater than 1, it's going to be an enlargement. If k is less than 1, it is going to be a reduction. Okay? So, those are our 4 transformations. Those are our 4 transformations and the rules that go along with it. Nice little review, everything all in one place. Any questions, leave it in the comments. If not, good luck, nerds.